In this video, we'll take a look at the most asked homework questions from section 1.4, Composition of Functions. The first question is question number 12. Given two functions, f of x is 1 over x plus 4 and g of x is 12 over x plus 2, find f composed with g of x. So the first thing we'll do is find f composed with g of x. So f composed with g of x means to take the function g, the entire function g, the formula, which is 12 over x plus 2, and substitute it in for x in the function f. The function f is 1 over whatever x is plus 4. So in this case, we're going to substitute in there the 12 over x plus 2. So now the next step to simplify that, if you haven't worked with complex fractions, is we have 12 over x plus 2 and 4. Find a common denominator for all the items in here, and then multiply the numerator and denominator by the common denominator. That's how you simplify a complex fraction. So the only denominator we have is x plus 2. So I'm going to multiply the numerator by x plus 2 and the entire denominator by x plus 2. And what that will do is it will get rid of our fractions, and it will get rid of our complex fractions. So in the numerator, 1 times x plus 2 is x plus 2. In the denominator, 12 over x plus 2 times x plus 2. The x plus 2's cancel, and I'm left with 12. So we're multiplying x plus 2 times each term in here. Now we have x plus 2 times 4 is 4 times x plus 2. Simplify your expression. We get x plus 2 over 12 plus 4x plus 8. Add like terms, we end up with 4x plus 20 in the denominator. So our function f composed with g of x is equal to x plus 2 over 4x plus 20. All right, the next part of the question asks to find the domain of our composition of functions in interval notation. So I've copied and pasted from your textbook a general note on the domain of a composite. So the domain of a composite function, f of g of x, is the set of those inputs x in the domain of g for which g of x is in the domain of f. So if that sounds a little confusing, what it means in a step-by-step is find the domain of your function g, find the domain of f, and then find the inputs x in the domain of g for which g of x is in the domain of f. Okay, so here's what that means to do. So first of all, g of x is what we're going to substitute into our function f. Okay. So what is the domain of g of x? G of x is 12 over x plus 2. So x cannot equal negative 2, because negative 2 is what makes the denominator 0. Okay? Domain of f of x, 1 over x plus 4. X can't equal negative 4, because that's what makes the denominator 0. Now we take a look at our f of g of x. Which equals x plus 2 over 4x plus 20. So we know in the function g of x, we can't put a 2 in there. So x can't equal negative 2 in our composition either. So if we take a look at the composition, is there anything besides negative 2 that we can't put in there? Okay, we take 4x plus 20, set it equal to 0, because the 0 can't be in the denominator. 4x equals negative 20, divide both sides by 4. Negative 20 divided by 4 is negative 5. So x can't equal negative 5. Okay? So it ends up that x can be anything except it can't be negative 5 because that's in the composition of functions. And it also can't be negative 2 because that couldn't be in the domain of g in the first place. So our domain is everything from negative infinity to negative 5, along with negative 5 to 2, along with 2 to infinity. So that's another way to write in interval notation that x can't equal negative 5 and x can't equal negative 2. That should be a negative. All right. The second question most missed in this homework, or most asked about, was to find two non-trivial functions, f of x and g of x, so that when we compose the two functions, we end up with 8 over x minus 1 squared. So we want to find two functions, f of x and g of x, so that when we substitute a composition of functions and put g of x, we end up with this answer. So probably the easiest way to do this, and the way I think of this, is let g of x equal that x minus 1. And then let f of x equal, wherever this expression is squared, f of x could equal 8 over x squared. That's one way to do it. So you notice when you take f of g of x, when you're going to substitute the g of x function, what will happen is you get 8 over x minus 1 squared. Now that's not the only combination of functions that'll work, but that's one that'll work. So your function f of x, the 8 over x squared, your function g of x, x minus 1. Okay, you could also have f of x is 8 over x, and g of x equal 8x minus 1 squared. So that's another way you could write that. You just want any two functions so that when you put the composition together, you end up with the given function.